This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 3, Lesson 1, Optionals. Safety is one of the big goals of Swift. Bugs are commonly created when you're referencing not having something. Swift has an interesting solution, which is optionals. Here we define a book type, where we have a name, which is a string, and each book has a publication year, which is an integer. And then we create two books and put in the publication year, and then we're creating an array of books. But what if we want to represent a book that hasn't been published yet, or for which the publication year is unknown? If we put 0 for the unknown publication year, that would not be accurate because that would mean the book is over 2,000 years old. The current year is not accurate either, because even if we had a new unannounced book, it might be released next year. There's no known launch date. We don't want to put incorrect information in our data structure. Our publication year is of type integer. It's tempting to want to put nil in the publication year because we don't know what the publication year is, but that's not valid. Our publication year is type integer. Nil is not an integer, so the compiler will throw an error. Here is Swift's solution. We change the publication year to be an optional int. We specify it by putting the type int and then the question mark immediately after it when we're defining the type to indicate that it is an optional of the underlying type. And then when we create our books, we could create a book with an integer publication year, or we could create a book where we set the publication year to be nil. Anything can be optional, any type, string, any struct. You can have the string type or you can have an optional string type. We have to be careful when we're specifying the type of a variable or constant where we want it to be an optional. Here, we're creating a new variable server response code and we make it equal 404, which is an integer. The compiler will infer that this is an integer. If we wanted server response code to be an optional integer, it is not sufficient to simply assign it nil, because the compiler does not know if this nil should be an optional integer or an optional string or an optional whatever. It has no idea. So the compiler will throw this as an error. Whenever you want to specify an optional, you have to explicitly specify the type. In this case, server response code is of type optional int, and then we can set it to an integer or we can set it to nil. Now we have optional values and we need to unwrap optional values to get at the underlying value, assuming that it is not nil. One way is to do force unwrap. Here we test publication year to verify that it is not nil. Since we're certain it's not nil, then we can forcibly unwrap it by using an exclamation mark after the optional publication year to get an actual integer. In this case, actual year will be a new constant, which will be of type integer, not optional integer. And then we can print out the actual integer. Alternatively, we could try to forcibly unwrap publication year using the exclamation mark without first testing that it's nil or that it's not nil. However, if it was nil and we forcibly unwrapped it, then our code would crash and execution would be terminated. Because it is so common to need to work with optionals, Swift has some shortcuts that are simpler than explicitly comparing to nil and then forcibly unwrapping. This code example is the if-let syntax or optional binding. In this case, we have an optional and we use if-let to unwrap it into a non-optional. If this is successful, then this new name will be an unwrapped or non-optional constant and we will execute this code. If some optional was nil, then this optional binding would fail and we would not execute this code. Here's a second example where we unwrap the book publication year, which, if you remember, was optional. And now we have an unwrapped publication year, and we can print out the unwrapped publication year. This is a non-optional integer, so we won't have any optional in our printout. And we can include an else clause for the case where publication year was nil and print out an appropriate error message. In these examples, we're using if-let to create a constant, but if we wanted, we could use if-var and have this new variable name be this new name be a variable. But of course, that variable would only be valid and visible inside the scope of these braces. The integer type has an initializer that takes a string. So if we have a string 1, 2, 3, then we can initialize an integer with using the string as a parameter, and in this case possible number will be an integer of 1, 2, 3. But what if the string didn't make any sense as a number? What if we try to initialize an integer using Cynthia? You can't convert Cynthia into an integer. So this initializer for int, where you're passing in a string, actually returns an optional int. So in this case, possible number would be an optional int of 1, 2, 3, and in the second case, possible number would be an optional integer where the value would be nil. Here's how we can do function declarations using optionals. In this case, we're printing a full name, and we assume that everybody has a first name and everybody has a last name, so those parameters are non-optional strings. However, some people don't have middle names, so we make the middle name an optional string, and then our function in its implementation, depending on whether middle name has a string value or a nil value, can print out an appropriate full name. Here's an example where a function returns an optional string, where we pass in a URL and we're attempting to get the text from the URL, and we might succeed or we might fail. If we succeed, we return the string, and if we fail, our function returns nil. We saw that the initializer for integer, where you pass it a string, could return nil. If the string that you passed it made sense, then it would return an integer, and if the string that you passed it did not make sense, for example, Cynthia, then it would return nil. That's called a failable initializer. A failable initializer is an initializer that can return nil. Here we have a toddler class, and our member-wise initializer, by default, we'd pass it the birth name, which is a string, and we'd pass it months old, which is an integer. But what if we wanted to create a toddler, or attempted to create a toddler where we passed it months old 144? Well, that person would be 12 years old. That's not a toddler. So we would want an initializer that would reject that and return nil in that case. Here is our optional initializer for our toddler. We have init, but after the init and before the parameters, we put a question mark. This indicates that this is a failable initializer, and it might successfully initialize a toddler, or it might return nil. And then we have put our checks to make sure that our parameters are valid. So we will only allow a toddler to be created, initialized, if the months old parameter is greater than or equal to 12 or less than or equal to 36. In this case, we are rejecting the invalid values, and when we do that, we immediately return nil. That means that the initializer has failed. Else, in this case, our parameters are valid, then we initialize our struct and set all of our properties. And in the initializer, when you're successful, you don't need to explicitly return. Instead, you just have to initialize all of the properties before you exit. And the compiler will check that you have initialized all of the properties. Here we are using our failable initializer. So we attempt to create a toddler, we pass in our parameters to the initializer, and we create a new constant. This constant is named possible toddler. It is of type optional toddler because the toddler initializer is a failable initializer, and the compiler knows that. Then we attempt to unwrap the optional toddler into a non-optional toddler. If we successfully unwrap the non-optional toddler, meaning the possible toddler is not nil, then we can use the toddler and print out its properties. Else, in this case, possible toddler was nil, then we print out an appropriate error message. Here we have three structs with optional properties. A person might have a residence. a residence might have an address, and an address might have a building number, it might have a street name, and it might have an apartment number. So we have lots of optionals in this data structure. We can use the if-let syntax to unwrap each of the optionals in sequence. And this will work fine, however, it can be quite tedious. In this case, we get what is commonly referred to as the pyramid of doom, where we have if followed by if followed by if just going across the page. The more terse alternative is to use optional chaining. In this case, we want to access the apartment number if it exists, but if it does not exist, we want nil. And we can do that with one if-let statement, where every time in our data structure it could be optional, we use a question mark. So person dot residence might have a residence, might have an address, and then we pull out the apartment number. And if all of those are non-optional, then the apartment number will go in our new constant. If any of these are optional, then the optional chaining will terminate at that point and we will get nil, but we will not have a crash. And then we can, our if-let, we will conditionally execute, if the optional chaining is successful and we get a actual apartment number, then and only then we will execute the code between these braces. Otherwise, we would continue on or execute the else clause. When you are defining a variable, you can use an exclamation mark in the type to mark it as an optional, however, make it so it will be automatically unwrapped. This is not something you should use often. You should only use that if you cannot set the variable during initialization, but you know and are completely confident that it will be set shortly thereafter. Implicitly unwrapped optionals are commonly used with UIKit, but are rarely used otherwise. If later in the code you were to access label and have it be unwrapped automatically on your behalf, but if it was actually nil, then your code would crash. That is why using implicitly unwrapped optionals is not recommended, other than the special case of UIKit. Optionals are a great language feature. Compare Swift to Java. In Java, every string is in effect an optional string. Every string could be nil. Anytime you use a string in Java, if you get nil and then you try to print it out, then you'll have a crash. In Swift, if you have an optional string, the compiler will protect you and make sure you unwrap it before you attempt to use it. And if you have a non-optional string, then you have confidence in Swift that you actually have a string and you can use it and print it out without fear. That's it for Unit 3, Lesson 1. If you're following the Apple curriculum, now is the time to open up the Optionals Playground and complete the exercises in the lab. The slide deck is copyright 2021 by Apple and is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.